This is 2018 paper 1 in higher maths. Okay, question 1 is asking you to find the median through R. So the median will meet the opposite side in the middle. So you need to find a midpoint. The point that the median is coming from is R, so that's 3, 6. We'll need to find a midpoint of PQ, which is -2, 4 and 4, 0. The reason we need to find a midpoint is because in order to find the gradient will be from the line R to the midpoint. So let's find the midpoint of P and Q. So the midpoint will equal -2 plus 4 over 2 and 4 plus 0 over 2. -2 plus 4 is 2. 2 divided by 2 is 1. 4 plus 0 is 4. Divided by 2 is 2. So the midpoint of PQ is 1, 2. Now the gradient will be between the midpoint and the point R. So we'll label it x1, y1, x2, y2. The gradient formula is y2 minus y1 over x2 minus x1. So 6 minus 2 over 3 minus 1, which is 4 over 2, which is 2. The equation is in the form y minus b equals mx minus a. Now you can use the point R or the midpoint. So I'm going to use the point R. So y minus 6 equals 2x minus 3. Then just multiply the 2 through on the right hand side and we get 2x minus 6. Normally I move the number from the left hand side onto the right hand side, but when you do that in this case you're going to end up with 0 because -6 plus 6 will give you 0, so we are done. The answer is y equals 2x, and that's our equation of the median through R. Okay, on to question 2. We're given a function g of x equals 1/5 x minus 4, and we're asked to find the inverse function. How I do this is I just let y equal 1/5 x minus 4, and then I change the subject of the formula to x. So I'm going to move my 4 over and leave my 1/5 x on the right. Then I want to multiply my 5 up with everything on the left, and that'll tell me what x is. Just rewrite it. So x equals 5 bracket, or sorry, we'll multiply out the 5 through the bracket now, so 5y plus 20. And that's us nearly done. Just where the x is, you now call that okay, that's us nearly done. All we do now is replace the x with the inverse function, and we replace our y with an x. So the inverse of g of x equals 5x plus 20. Now on to question 3. h of x equals 3 cos 2x, and we can think of this as 3 cos of a bracket 2x. So when we differentiate cos and we get minus sign, so I'm going to write minus 3 sign. We keep the bracket the same, and then we have to remember to times by the bracket differentiated. So we're going to multiply by 2. Then tidy that up, it would be -6 sine 2x. And at this point we can remove the bracket again. we were asked to find h dash of pi over 6. That just means 30 degrees, because 180 divided by 6 is 30. So if we convert that, the radians into degrees, we get 30 degrees. And 2 lots of 30 will be 60 degrees. You should know from your exact values table that sine 60 is root 3 over 2. Which negative 6 root 3 all over 2 will be negative 3 root 3. 6 divided by 2 gives you 3, so negative 3 root 3. Now on to question 4. You're asked for the equation of a tangent to a circle at K. So we've got your circle, you've got your tangent. Just remember that the tangent will always be at right angles to the radius. So K is 8, negative 5. To find the centre of the circle, 2g equals negative 12, so g equals negative 6. 2f equals negative 6. F equals negative 3. So your centre is negative g, negative f, which is 6, 3. So 6, 3 is in here. Okay, to find the equation of the tangent, we just need to find the gradient from the centre, put a C on the centre, the gradient from C to K. So we'll do our gradient formula. We could actually let out like a point gradient equation, since a tangent is a straight line. Okay, so the point we can use has to be K, because C is not on the tangent, so it has to be K. You don't have a choice here. To find the gradient, we're just going to use 6, 3 and 8, negative 5. Now the gradient won't be that, it'll be the perpendicular of that. So find the gradient of CK first, and then we'll have to flip it upside down and change its sign. Okay, so we get negative 4. That means the perpendicular gradient is 1/4, since m1 times m2 equals negative 1. Okay, now we just do y minus b equals mx minus a, using our point and gradient. So y plus b, because 2 negatives make a plus, and remember to use the quarter. Now, because it's a quarter, I'm going to multiply the left-hand side by 4, but remember to multiply both parts. And then we've got the 1 to multiply through on the right-hand side. So the right-hand side will just be x minus 8. Add 20 onto the 8, or sorry, subtract 20 from the 8. You're going to get negative 28. Okay, so 4y equals x minus 28. If you wish, you can divide through by 4 and leave it as y equals 1/4 x minus 7, but there's no need. So I leave it in that format. Number 5. Okay, we've got 3 coordinates and they are collinear. That just means they lie on a straight line. So state the ratio in which b divides ac. So in this case, we just do a to b and b to c. A to b is b minus a. B is 5t5. And a is minus 3, 4, minus 7. So 5 minus 3 is 8. T minus 4 we can't work out, so just leave it like that. 5 minus 7 is 12. Let's do the same for BC. Seven minus 5 is 2. 9 minus t we can't work out. 8 minus 5 is 3. Okay, you normally simplify these down. We can't simplify the middle term because we don't know it, but we can simplify. We can clearly see that AB is 4 times the size of BC if you look at the 8 and the 2 and the 12 and the 3. So I'm going to take a 4 out as a common factor and put the BC answer in here. So 4 2s are 8 and 4 3s are 12. So we can clearly see that the ratio of A to B and B to C is 4 to 1. So that means that B divides AC in the ratio 4 to 1. If you want, over on this right hand side, you can write the 1 to remind you that 4 lots of 2, 9 minus 2, 3 for AB, and BC is 1 lot of 2, 9 minus t, 3. So that's why it's ratio 4 to 1. Part B, state the value of t. So that was part A we did. Okay. 4 lots of 9 minus t must be equivalent to t minus 4. So let's just multiply that through. So 36 minus 4t equals t minus 4. So 36, actually I'll add the 4 onto the 36, I'm going to get 40. I'm going to add the 4t onto the t on the other side, I'm going to get 5t. So then we'll go over here, t equals 40 divided by 5, which is 8. So the answer to A was 4 to 1. The answer to B, t equals 8. Number 6. We're going to find the value of this log question. It's base 5, not base 2. Okay, remember we can bring numbers up at the front as a power, so that'll be 8 to the third. 8 to the third means cube root, so I'll do that at the side. Cube root of 8 equals 2. 2 times 2 times 2 is 8. So we can write that as log 2 to the base 5. Now we can join the logs together, got the same bases. We're going to divide. This is one of our laws of logs. If we wanted to combine two that are being subtracted, we do a division. 250 divided by 2 is 125. Okay, at this point, you're just trying to say to yourself, 5 to the power of what equals 125? 5 cubed. So the answer is 3. Now on to number 7. 7a is write down the coordinates of P, the point where the curve crosses the y-axis. So if it's crossing the y-axis, the x value must be 0. So this is really easy. All we do is replace the x's in the equation with 0. Okay, so the first two terms go to 0, you're just left with a 5. So therefore, P equals 0, comma 5. Make sure you put it in a bracket with your comma. Part B. Determine the equation of the tangent to the curve at P. Okay, to find the equation of a tangent to a curve, we differentiate and sub in our x value. That'll give us the gradient to the tangent. So I'll write out the equation first and then we'll differentiate that. Okay, so dy by dx is 3x squared minus 6x plus 2. Now, the gradient of the tangent will be when x equals 0, because your p-value, the x value is 0. So it's not always 0. So when x equals 0, dy by dx equals, it's going to equal 2. So the gradient of the tangent is 2. We've got our gradient, we've got our point. It's just a matter of finding your equation. Okay, so let me highlight. So our point is 0, 5. Our gradient is 2. Let's now just do y minus b equals mx minus a. So y equals 2x plus 5 is our equation of the tangent to the curve. To find the coordinates of q, the point where the tangent meets the curve again, we just substitute, well, we basically just put them both equal to each other. So we're going to put the curve equal to the line, the tangent that we've just found out. So x cubed minus 3x squared plus 2x plus 5 equals 2x plus 5. Okay, the 2x plus 5s actually cancel because they're both positive on different sides. So they will cancel out. So you just get x cubed minus 3x squared equals 0. Take out x squared as the highest common factor. And you get x minus 3 in the bracket. So x squared equals 0, which just means x is 0. Or x minus 3 equals 0. So x equals 3. Now, for p, the x value is 0. So for q, the x value is going to be 3. To find the y coordinate, I would always sub it into the easier equation. So I'm going to sub it in to this one here. So 2 times 3 plus 5 equals 6 plus 5, which is 11. So therefore q is 3, 11. Okay, question 8. You've got y minus root 3x plus 5 equals 0. We want to rearrange that in the form y equals mx plus c, so we can see the gradient. Anytime you see positive direction of the x-axis, that just means m equals tan theta. Okay, so we're going to use m equals tan theta. Then we'll be able to find the angle that we're looking for. So from y equals root 3x take away 5, you can see that the gradient has to be root 3. So we just put tan theta equal to root 3. And from your exact values table, you should remember that theta would therefore be 60 degrees. On to question 9. Express BC in terms of u and t. I'll draw the front part of the triangle so you know what we're talking about. So it's a triangular prism. B's here, C's here, A's here. This is u and this is t. And you were asked for BC. To get from B to C, using the vectors that we know, we have to do minus t plus u. We're supposed to underline our vectors because we can't print them when we're writing them. So just underline them to show that they're in bold. So BC equals minus t plus u. That was for 9a. 9b. M's the midpoint of BC. Okay, so it's asking us express MD in terms of TU and V. MD is a half BC plus CA plus AD. We already know BC is minus t plus u, so it's just a half of that. So minus a half t plus a half u. Just multiply your half through both of them or take it out as a common factor. CA is minus u because it's going against the arrow, and AD is V that you can't see on the diagram I've drawn above, but if you look at the question paper you'll be able to see it. So the vector V is AD. We've got two sets of u's, so just join that together. So it's minus a half t minus a half u plus V. And that's your final answer. On to question 10. dy by dx equals 6x squared minus 3x plus 4. And we know the coordinate x equals 2 when y equals 14, so I'll just pop that at the side. Right, we have to express y in terms of x. So y is going to be the integral of 6x squared minus 3x plus 4. Make sure you put your dx in, don't lose marks for that. Okay, so add 1 onto the power, divide by that new power. And just remember to put an x on numbers. Also, we must have a plus c in. Okay, we can tidy that up a little bit. So 2x cubed plus 3x squared over 2 plus 4x plus c. Now, we don't want to leave our answer with a plus c, so that's why they've given us the coordinate. So put the coordinate in. So 14 is your y value, and your x value is a 2. Okay, so you're going to get 14 equals 18 plus c, so c is negative 4. And then you just want to write out your equation, but with your c in it. So y equals 2x cubed plus 3x squared over 2, or 3 over 2x squared, whichever way you prefer to write it, plus 4x minus 4. And that's us. Done question 10. Okay, let's do question 11. Okay, if we turn the log graph upside down, we will have drawn minus log x to the base 3. But we want to draw 1 minus log x to the base 3. So that will be the same as just lifting this graph up one position. So if we move that up one position, okay, it should make sure it's cutting at 3. And I would give the coordinate of 1, 1 because you've moved that up one position as well. So mark in your x-axis, mark in your y-axis, and this graph here is y equals 1 minus log x to the base 3. So it's probably a good idea to show the negative log x to the base 3 first, and then show that you're moving it up one position. Okay, for part B, determine the exact values of the x-coordinate of the point of intersection of the two curves. So they're talking about the curve you started with. The curve that was given in the question was y equals log x to the base 3. So we're just going to put them equal to each other and solve it. Okay, so we've got 2 log. If we add the log on the right to the log on the left, we have 2 log x to the base 3. We can bring the 2 up as a power. And where the 1 is, I'm going to replace that with 1 log 3 to the base 3. So the 1, if the 1's there, you can just bring it up as a power and then remove it. But 3 to the power 1 is just 3, so I'm going to rub out that power. Now you can just put x squared equal to 3. So sorry, that's x squared, not x cubed. So x squared equals 3, so x equals plus or minus root 3. But because x has to be greater than 0, the answer will be x equals root 3. So you must explain why we're disregarding the negative if you mention it at all. On to question 12. Express 2a plus b in component form. So 2a plus b is just two lots of the a, and the a is 4 minus 2, 2, and the b is minus 2, 1, and then a p. So we don't know what that value is. So if we multiply the 2 by the 4, we get 8. We get minus 4 and 4. 8 plus minus 2 is 6. Minus 4 plus 1 is minus 3. And 4 plus p will just leave us 4 plus p. That was part A. Part B. Hence find the values of p for which the magnitude of 2a plus b equals 7. So to find the magnitude, you would just square and square root. So 6 squared plus, just put negatives in a bracket so that you're making sense. Let's work that out first and then we'll put equal to 7. So 36 plus 9 plus 16 plus 8p plus p squared. We can tidy that up. We get p squared plus 8p plus 61. Okay, now we can put that equal to 7. Okay, get rid of the square root, just square the 7, which is 49, and then subtract the 49 from the 61 and we get 12. Now just factorise that. So it's p plus 6, p plus 2. We can put both brackets equal to 0. So p equals negative 6 or p equals negative 2. Question 13. Okay, we've got a right angle triangle and we're asked for exact values, so we'll need to find the sine and cos. So the first thing we need to do is do a little bit of Pythagoras to find the missing side. So square the square root of 11 and you get 11. Square the 2, you get 4. 11 subtract 4, you get 7, and then square root. So that'll be the square root of 7. Let's work out sine x and cos x. So sine x equals opposite over hypotenuse, so 2 over root 11. And cos x equals adjacent over hypotenuse, so root 7 over root 11. From the exact values table, this is part A. From the exact values table, it tells you that sine 2x equals 2 sine x cos x. So we just multiply both of those answers together, along with the 2 at the front. Okay, so 2 2s are 4, so 4 root 7. Root 11 times root 11 is just 11. So 4 root 7 over 11. Okay, part 2. Cos 2x. This is the only time I would use the first formula, which is cos squared x minus sine squared x. Normally we use the second or third when we're replacing it, depending on what the other terms are in an equation. Anyway, I would use cos squared minus sine squared here, but you can use any of the three, so it doesn't matter which one you've used. Okay, so root 7 over root 11 all squared minus 2 over root 11 all squared is root 7 times root 7 is 7, root 11 times root 11 is 11, 2 squared is 4, and that would be 11, so 3 11ths. Part B. They're asking for sine 3x, but they've told us to split it up this way because you can't work out sine 3x. You have to do it like a double angle formula and an expansion like an addition formula. So the addition formula for sine is sine cos sine. So sine 2x cos x, keep the sign the same, so if it's a plus, keep it as a plus when you're doing a sine expansion. And then it'll be cos 2x sine x. And then just pop in what you've already learnt from part A. So sine 2x was 4 root 7 over 11. Cos x is root 7 over root 11. Cos 2x was 3/11. And sine 2x was 2 over root 11. So root 7 times root 7 is 7. 4 7s are 28. So it'll be 28 over 11 root 11. And 3 2s are 6. And then that'll be 11 root 11 as well. You can't tidy that together. Okay, now we've got the same denominators. You can just do 28 plus 6, which is 34. And put your denominator down. So 34 over 11 root 11, and that's your final answer for part B. Okay, question 14 is evaluate between 9 and -4 1 over the cube root of 2x plus 9 squared. Right, that's the same as 2x plus 9 to the -2/3, because it'd be 2/3, but it's on the denominator, so -2/3. So to integrate that, keep the bracket the same, add 1 onto the power, so you get 1/3, divide by the 1/3, and also divide by the bracket differentiated, so I'm going to multiply a 2 into that denominator, and that will be me dividing by 2. So on the denominator, you're going to have 2/3. So we can bring the 3 up, and that'll be a cube root of 2x plus 9. And on the denominator, you'll just have a 2. Now we're ready to substitute our 9 and our -4 in and subtract. Make that look like a cube root. Hold on. Okay, so I'll just go up here. 2 9s are 18, plus 9 is 27. So it's 3 and then the cube root of 27, which we can work out in a wee second. Take away, now I'm onto the second bracket. 2 times -4 is -8, plus 9 is 1. The cube root of 1 is just going to be 1, so that'll work out nice in a wee second. Cube root of 27 is 3. So 3 times 3 is 9, so 9 over 2. Cube root of 1 is 1, so that'll just be take away 3 over 2. So 6 over 2, so our final answer is 3. Okay, the last question, 15. Okay, so let's draw a graph. We're told that there's a repeated root at 2. They're telling you that x plus 4 is a factor, which means it must be cutting through -4. That must be a root. Okay, and it's telling us that there is a stationary point at -2, because they're saying that f dash of -2 equals 0. That means there's some sort of stationary point, either a turning point or a point of inflection at x equals -2. So I'll put a -2 on here, but that's not going to be a root. That's just going to be a place where there'll be a turning point, but not necessarily on the actual x-axis. Okay. They're also saying that there's a positive gradient where the function crosses the y-axis. So that makes me think the graph is going to be coming up from here and then turning, so a repeated root at 2. So it has to have a positive gradient crossing the y-axis, which it does. It's got a repeated root at 2. At -2 it has to turn. So I've turned it here, and then it's has to cut through at -4. So that would be an example of y equals f of x. Repeated root at 2, cutting at 4, positive gradient crossing the y-axis, and a stationary point when x equals -2.